Hello, my dear students. Let us discuss cell structure of algae and criteria for algal classification like pigments, reserve food material, and flagella. So let us discuss detail. There are two types of cell structures present in algae. One is prokaryotic cell and another one is eukaryotic cell. In prokaryotic cell, the nuclear membrane is absent and histone proteins are absent. We know very well. Only one class is show the prokaryotic cell. That class is Myxophyceae or Cyanophyceae or Cyanobacteria or BGA, blue-green algae. The class belongs to prokaryotic cell. So according to which classification, only one class belongs to prokaryotic organism, that is Cyanophyceae or Myxophyceae or Cyanobacteria or blue-green algae. Except Cyanophyceae, remaining all classes are to show the eukaryotic cell. In eukaryotic cell, we discuss stepwise. First one is a cell wall. The cell wall is always formed outside the plasma lemma or cell membrane. Structurally, the cell wall may be incomplete or complete. So on the organism, it is made up of unicellular or multicellular. Each cell on the cell membrane or plasma membrane or plasma lemma, a special layer is present. That layer is called cell wall. This cell wall may be completely surrounded by the cell or incompletely surrounded by the cell. If incomplete cell wall is the characteristic of several flagellates and usually termed as lorica. The lorica means the incomplete cell wall is characteristics of several flagellates. So which organism did not contain complete cell wall, simply termed known as lorica. The cell wall in most of the algae is composed of water soluble carbohydrates like cellulose, mannose, and chitin. So most of the algal members, the cell wall is made up of cellulose and some are mannose and chitin. Cellulose, mannose, and chitin are the water soluble carbohydrates. The cell wall in Xanthophyceae mainly contain pectin. Pectin is the non-water soluble carbohydrate. So in Xanthophyceae, the cell wall is mainly contain pectin. In Chlorophyceae, Rhodophyceae, Phaeophyceae, and Dinophyceae, the pectin is mixed with cellulose. And then Bacilloraphyceae, popularly known as diatoms, along with cellulose and silica granules are also present. Cellulose, pectin, and silica granules are present in the Bacilloraphyceae. So very important, silica granules are present in the diatom cell wall. In coralline membranes of Rhodophyceae, the cell wall is being deposited with calcium carbonate. So coralline members Rhodophyceae and Chlorophyceae, Chara is also contains calcium carbonate in the cell wall. And euglena and gymnodium, these two algal organisms, instead of true cell wall, the pellicle is present. So true cell wall, cellulose is absent. Instead of cell wall, pellicle is present in euglena and gymnodium. The alginic acid is present in the intracellular spaces and cell walls of the Phaeophyceae. So the Phaeophyceae algal members, in the cell wall, alginic acid is present. This alginic acid, where it is located, intracellular spaces and cell wall. And fucoidin is also occurs in the Phaeophyceae. So most important, in Phaeophyceae algal members, two are present. One is alginic acid and fucoidin. Both are present in the cell wall. In Rhodophyta, the amorphous component of the cell wall is composed of galactons or polymers of galactose. In the Rhodophyta, the cell wall contain galactons or polymers of galactose. These galactons include agar. The agar is made up of agaropectin and agarose. And another type of galactons are carrageenan. So in the Rhodophyta, in the cell wall, which are present, polymers of galactone or galactons are present. Best example of the galactons are agar and carrageenan. And flagella, it is the chief characteristics of the algal organisms. So most of the algal organisms to possess flagella. It is plural word, singular is flagellum. The flagellas are thread-like structure concerned with cell movement and found in almost all the classes of algae. But in some algal members, example Rhodophyceae and Cyanophyceae, the flagella was completely absent. In which are classes? Rhodophyceae and Cyanophyceae, flagellas are completely absent. A flagellum grows from the basal body of the biparoplast. So the flagella arises from the biparoplast. So another name of the flagella is known as cilia. Cilia means a term of short flagellum is called cilia. And each flagellum consists two central fibrils surrounded by 9 peripheral double fibrils. That arrangement is 9 plus 2. So if the transverse section of the flagellum, 9 double microfibrils are arranged in peripheral region and center part 2 is present, that arrangement is called 9 plus 2 arrangement. A cell having flagella is also known as motile cell. So a flagellum consists of an axoneme of 9 doublet microfibrils that surrounded 2 central microtubules. Now just we discuss the flagellum under the transverse section to show the 9 plus 2 arrangement. That means the 9 plus 2 microfibrils consist the axoneme. The axoneme microtubules are composed of alpha and beta tubulin. So the flagella is made up of axoneme. Axoneme is made up of alpha and beta tubulin. The 9 plus 2 arrangement is seen only in the eukaryotic organism flagella. Prokaryotic organisms, if they possess flagella, they did not show the 9 plus 2 arrangement in their transfer section. The flagellum possessed through the tunnel in the cell wall, that region is called flagellar collar. So where the flagella come outside the through cell wall, that region is called flagellar collar. In algal members, there are mainly two types of flagella are seen. What are they? First one is whiplash or acronematic flagella. That means the flagella surface is very, very smooth. So seen in this diagram, on the flagellum, there is no hair-like structures are present. The flagellum is very, very smooth. The type of flagellum is called whiplash or acronematic. And second one is a tinsel flagella or pleuronematic flagella. Here in the surface of flagella is covered with fine hair-like appendages called mastigonemes. So the cell wall, so the flagella surface is not smooth. They're covered with small hair-like appendages. Now the type of flagella is called tinsel flagella or pleuronematic flagella. The small hair-like appendages are called mastigonemes. On the basis of their arrangement of mastigonemes, tinsel flagella may be pantonymatic, pantochronymatic, and stichonymatic. First one is pantonymatic. These flagella have two opposite rows of mastigonemes. If you see in this picture, on the flagella, the hair-like appendages are known as mastigonemes. The mastigonemes are arranged in opposite rows. So two sides hair-like appendages are seen on the flagella. They are called pantonymatic. And pantochronymatic is having terminal fibril. So on the flagella or flagellum, the tip part is also fibril is present. The end with fibril, terminal fibril, they are called pantochronymatic. And stichonymatic flagellum, in this mastigonemes developed only one side of the flagellum. So see in this diagram, the mastigonemes are arise only one side of the flagellum. So these are the three types of flagella in tinsel or pleuronematic flagella: pantonymatic, pantochronymatic, stichonymatic. If the flagella are of equal length, they are called isochond. So the flagella both are in same height, they are called isochond. If they are unequal in length, they are called anisochond. That means on the cell, one flagellum is very, very long and another flagellum is very, very short. So both are unequal, they are called anisochond flagella. If they are formed at the ring at one end of the cell, they are called stephanochond flagella. So especially in Oedogonium, the tip part, a ring-like flagellas are arranged. If a ring-like flagellas are arranged grouply, they are known as stephanochond flagellum. And heterochond, that refers means to an organism with an hairy and smooth flagellum. Heterochond means on the cell, one is whiplash and second one is tinsel. Whiplash, tinsel. Different type of flagellums are present. Now they are called heterochond. Both are equal, isochond, flagella both are unequal, anisochond, and a ring-like flagellas are arranged in a ring-like manner or corona-like manner. They are called stephanochond. And different type of flagella present on the same cell. One is whiplash, another one tensile, that is called heterochond. And another one is to play key role in the classification of the algae. One is plastids. The basic type of plastid in the algae is chloroplast. The plastid capable of photosynthesis. Chromoplast is a synonymous with chloroplast. The basic structure of the photosynthetic apparatus in a plastid consists of a series of flattened membranous vesicles called thylakoids or discs. Generally, the plastids contain chlorophyll A and chlorophyll B. They are called chloroplast. Both chlorophyll A and B are present in the chloroplasts. Plastids, they are called chloroplast. Whereas those lacking chlorophyll B, they are called chromatophores. The chloroplast is different type of shapes are seen in different type of algae. The chloroplast is cup-shaped in Chlamydomonas. So in Chlamydomonas, the chloroplast is cup-shaped. Girdle-shaped or C-shaped in Eulothrix. Girdle-shaped or C-shaped chloroplast seen in Eulothrix. Discoid in Vacheria and Cara. So in Vacheria and Cara, discoid type of chloroplasts are seen in reticulate Oedogonium. So in Oedogonium, the chloroplast is reticulate or net-like structure. Spiral in Spirogyra. So the name is arranged from the chloroplast arranged in spiral manner. That's why the algae get the name Spirogyra. And stellate, a star-like chloroplast seen in the Gymnema. So in Gymnema, which type of chloroplast? Stellate. So in Chlamydomonas, cup-shaped chloroplast. Eulothrix, girdle-shaped or C-shaped chloroplast. Vacheria and Cara, discoid type of chloroplast. In Oedogonium, reticulate type of chloroplast. In Spirogyra, spiral-shaped type of chloroplast. In Gymnema, stellate or star-like chloroplast is seen. And chlorophyll. Is chlorophyll are the primary pigment in the photosynthesis. The chlorophylls are different type of chlorophyll seen. Chlorophyll A, B, C, D, E, and bacterial chlorophyll, chlorophyll, chlorophyll 650 and 660. But in algal members, to show the chlorophyll A and B and C and D and E. These are the 5 types of chlorophyll pigments are seen: A, B, C, D, E. A is the universal type of chlorophyll found from the lower organisms to higher organisms. That means from algal member and bryophyte, pteridophyte, gymnosperms, angiosperms, all lower to higher plants. The universal chlorophyll is chlorophyll A. But the remaining chlorophyll B, chlorophyll C, chlorophyll D, chlorophyll E, they are only saw in algae. So in chlorophyce, along with chlorophyll A, chlorophyll B is also present. In xanthophyce and chrysophyce, along with chlorophyll A, chlorophyll E and chlorophyll C is present. In bacillariophyce and phaeophyce, along with chlorophyll A, chlorophyll C is also present. And rhodophyce, along with chlorophyll A, chlorophyll D is present. So specific we seen chlorophyll B seen in chlorophyce, chlorophyll E and C seen in xanthophyce and chrysophyce, chlorophyll C is seen in bacillariophyce or diatoms and phaeophyce, chlorophyll D seen in rhodophyce, algal members. And carotins, these are also necessary photosynthetic pigments. The formula is C40H56. And carotins are different types: alpha carotene, beta carotene, and gamma carotene. But alpha and gamma carotens are seen in all algal members from 11 classes: chlorophyce, phaeophyce, rhodophyce, xanthophyce. But beta carotene only seen in chlorophycin. So the common carotenes are alpha and gamma carotenes, but beta carotene is only restricted to chlorophycin algal members. And xanthophylls, these are also necessary pigments. Fucoxanthin is the characteristic pigment of the phaeophyta. Common xanthophylls are zeaxanthin, astaxanthin, lycopene, diatoxanthin, diadinoxanthin, acetoxanthin, and fucoxanthin. These are all common xanthins, but fucoxanthin is the chief characteristic pigment in the phaeophyta. And phycobiloproteins, they are water soluble blue or red pigments located in cyanophyta and rhodophyta or inside cryptophyta thylakoids of the chloroplast. So these phycobiloproteins are water soluble pigments. They are red or in blue color. The major blue chromophore occurring in phycocyanin and yellow phycocyanin is phycocyanobulin, also known as. So that phycocyanin and yellow phycocyanin is also known as phycocyanobulin. And red chromophore occurring phycoerythrin is also known as phycoerythrobulin. The general classification of phycobiloproteins is based on their absorption spectra. Most important, the phycobiloproteins are different types: phycocyanin, phycoerythrin, and yellow phycocyanin. They are differentiated based on absorption spectra. In the VIBGYOR, the visible light is 360 nanometers to 700 nanometers. So these phycocyanin, phycoerythrin, yellow phycocyanin absorb the different type of nanometers wavelength. So these phycobilins are differentiated with based on their absorption spectra. There are three types of phycoerythrins are present: R phycoerythrin, B phycoerythrin in the rhodophyta, and C phycoerythrin in the cyanophyta. So the three types of phycoerythrins: R phycoerythrin, B phycoerythrin, C phycoerythrin. C phycoerythrin seen in the cyanophyta, R and B phycoerythrins are seen in the rhodophyta. And there are also three types of phycocyanins: R phycocyanin from the rhodophyta, C phycocyanin, and yellow phycocyanin from the cyanophyta. So R phycocyanin seen in the rhodophyta, C phycocyanin and yellow phycocyanin is seen in the cyanophyta. And another important is reserved food material for the classification of algae, simply known as RFM. The food synthesized during the photosynthesis is stored in different forms in various classes of algae, which is known as stored food or reserve food material. Floridian starch and myxophycian starch and laminarin. These are all are high molecular weight sugars. Floridian starch, myxophycian starch and laminarin. These are high molecular weight sugars. Floridian starch, myxophycian starch, and starch, they show the alpha 1,4 linked glucans, but laminarin to show the beta 1,3 linked glucans. So first one is Floridian starch. In the Floridian starch, they show the alpha 1,4 linked glucans. The substances occurred in rhodophyta. The Floridian starch is reserve food material in rhodophyta. It is similar to amylopectin in higher plants. So this Floridian starch is resemble to the or similar to the amylopectin which is present in the higher plants. When this Floridian starch stains red violet with iodine, that means the Floridian starch react with iodine, it turned into the red violet. And myxophycian starch found in the cyanophyta Mixophycean starch as similar to structure to glycogen. So mixophycin is also alpha 1,4 linked glucans, which is present in Cyanophyta prokaryotic class. The starch is similar to the glycogen. The reserved food product occurs in the granules. And starch, alpha 1,4 linked glucan, they are also. It is seen in chlorophyta. Starch is composed of amylose and amylopectin. It occurs in the inside of the chloroplast. And laminarin, they are beta 1,3 linked glucans. This laminarin is reserved food material of Infiophyceae. The chrysolaminarin are also known as leucosin. This reserved food material is seen in the Chrysophyceae and Basilariosphyceae or diatoms. Paramylan, it is the reserved food material in Euglenophyta and Xanthophyta. And fructosans in Acetabularia chlorophyta has inulin-like storage product, that is fructosans, which is seen in Acetabularia. And the glycosides, the glycerol glycosides, fluoricide and isofluoricide are widely distributed in rhodophyta. So glycosides are commonly seen in the rhodophyte. There are different type of glycosides are present in fluoridicidae and isofluoricide. And polyols, these are the low molecular weight sugars. One of the main polyol is mannitol, which is occurs in rhodophyta and Phaeophyceae. So most of the textbooks in Phaeophyceae, the reserved food material is laminarin and mannitol, but laminarin and mannitol is the polyol, which is low molecular weight sugar, and laminarin is the high molecular weight sugar. They are beta 1,3 linked glucans. And pyrenides are additional cell organelles present within or on the surface of the chloroplast or chromatophore. Pyrenides are the proteinaceous bodies made up of densely packed proteinaceous fibrils and are on the site of accumulation and synthesis of starch. So pyrenides are commonly seen in the Chlorophyceae algal members. They are starch containing proteinaceous bodies. They are simply known as pyrenide. Single pyrenide seen in Chlamydomonas and more than one pyrenide seen in Spirogyra. But however, in Cyanophyceae, the pyrenides are completely absent. And next one is eye spot. It is also known as stigma. The motile vegetative and reproductive cells of algae have a pigmented spot called eye spot. The eye spot is considered to be light sensitive organelle which direct the movement of swimming the cell. On the basis of their position and structure, there are 5 types of eye spots or stigmas are present: type A, type B, type C, type D, type E. So whatever it may be, the eye spot to play key role in the movement of the flagellum by 3 ways. Photoaxis, first one is photophobia or photoshock, the gliding or quiescence. Photoaxis. In this photoaxis, the orientation of the cell movement is affected by the direction and intensity of the light. The photoaxis means the orientation of the cell movement is affected by the direction and intensity of light The cells move towards the light. Most important, the cells move towards the light in positive photo axis and away from the light in negative photo axis, like photophobia. The photoreceptor in green algae, Chlamydomonas, is chlamydosporin in valvaxosporin. These photoreceptors are contained in the plasma membrane of the eye spot. They play a key role in the movement of the cell. So photoaxis, there are two types, positive photoaxis and negative photoaxis. The cell move towards the light, positive photoaxis, and away from the or far from the light, they are called negative photoaxis. And photophobia or photoshock. Photophobia is the change in direction of movement of the cell caused by the rapid change in light intensity, irrespective of the direction of the light. They are far from the light side. They are called photophobia or photoshock. Third one is glidding. In glidding, the flagella stop beating and adheres to the surface or an air or water surface. So these are the three types of photoaxis, photoshock, and glidding. Photoaxis means the cell moves towards the light side. They are called photoaxis. And photoshock, they far or escape from the light side. They move to the dark side. They are called photoshock. And glidding, they did not show the any movement, but they attach to the substratum. Here, the between the two flagella, 180 degrees is present. So these two flagellas are attached to the surface. The angle between the two flagella 180 degrees, especially in bleeding or quiescence. And vacuoles act as the main osmoregulatory organ in the cell and help in regulating the absorption of water and solutes. So these are the components: flagella, reserve food material, and nucleus, and all are to help for the classification of algae.